Welcome to another episode of Code Study Sesh and OSRS AFK training. Right now I'm aiming to get to level 62 woodcutting. I got to 62 fishing. Mainly because I want to do these quests. Swan Song, I want to do Sins of the Father, Shadows of Custodia. So these require a bunch of levels. Construction is going to be really quick, so I'll probably actively train that, but woodcutting and all those kind of take a lot of time, so that's why I started just learning concepts while I do this, so it's productive. Interface type lists. When generics were released, the new way of writing interfaces was also released at the same time. Okay. Oh wow. Now we can simply list a bunch of types to get a new interface constraint. So this is probably like strict typing. Type constraint that matches any ordered type. An ordered type is one that supports these operators. Why might you create an interface using a type list? Well, if you want to know exactly what's going in. Ordered interfaces. I'm going to write this example down. And basically, ordered constraint supports An ordered type is one that supports the parametric constraints. Your interface definitions, which can later be used as constraints, could accept type parameters as well. Okay. I'm thinking, why? Parametric constraints. What do we do with that? Okay, so the store interface represents a store that sells products. It takes the type parameter P that represents the products the store sells. Okay, cool. So P is the product. So we're using some sort of generic interface sell P. Okay. Sell the product, price, and then float 64. Okay, so we're creating a generic of product. The store sells products. Okay. Types. So product type has a price and a name. Book struct has a title, author, and a price. As long as there's a string and a float 64, this satisfies that condition. toy price, float 64, toy name, string. But then book's got a price and name. So it just runs the interface on the struct. Or runs methods on the struct that work with this interface. Bookstore struct. Okay, let's see what this assignment's about first. A slice of any type that fulfills the built-in constraint comparable is also value. X is also value of the same type. Okay, so comparable is a useful constraint that makes it possible to use this. Okay. Let's look at this assignment. Let's not get overwhelmed by the code there. Let's see what exactly it wants. So we just look at the parts we need. Okay. Chief architect at Melio has decided she wants to implement billing with generics. Okay, cool. Specifically, she wants us to create a new biller interface. A biller is an interface that can be used to charge a customer and can also report its name. Okay, so there are two types of billers: user biller, cheaper, and org biller, expensive. Okay, so customer versus org. Customer is either a user on an org, user or an org. Okay. C customer, where's C customer? A user will be billed with a user biller, and org will be billed with that. Create the new biller interface. Should have two methods: charge and name. The architect already wrote the user builder and org builder types that fulfill this new builder interface. Use the definitions of those types and their methods to figure out how to write the builder interface definition. So usually the interface is just function and type. So we need to see what is being used here. So org builder, bill, and user builder, bill for charge. So if type bill, so as long as that satisfies, and the name is type string. Charge return bill returns a bill. Org returns a bill. And then customer interface, and then bill struct name string. Oh, it's biller customer C. Two methods, charge and name. And what does it take? It looks like it takes in an argument. There we go, pass. You have to pass in the name. So it looks like it passes in the user and it passes in the org, right? But because we have a generic customer, it's going to be type C. And then the name doesn't take in any arguments in here, and the name doesn't take any arguments in here. So in order to map this interface, we need to create a generic way to resolve both. Naming generic types. But I want to understand what the parametric constraint is. Parametric constraint. Naming generic types. Let's look at this example. So T any. This is a very general generic. So like my type any, my any type. T is just a variable name we could have named it anything. T happens to be a common, fairly common way to do it. This is also the way they do it in C, C++. Similar to how I is a convention for index variables, it loops. The name of a type parameter. Okay, so now we're on enums. So I think we should do this in a separate episode. So yeah, we'll continue in the next video where we do enums.